Okay, so from chapter 5, so what's important is like you guys have to know like how to set up the hypothesis, right? If they're different or not. So slide 6, 7, you guys. So 6 to 8 basically, you guys need to know that on like this is from intro to statistics, right? And you guys also need to know the conditions. So um, the conditions for setting up the hypothesis, so like they have to be independent, right? And there should not be too much of skewness, right? And there's like problem with small data sets, not small data sets, like small number of observations, right? So if n is small, then we won't get a reliable estimate. So that's from chapter 5. Actually, a few more things I would also like to talk about. It's also you guys need to know the normality conditions from the chapter 5, like slide 12 to 14. Right? It's actually been a while. Like we did this like maybe 1.5 months back. But you need to know the normality conditions. Okay, you can write this stuff in your cheat sheet. Okay, but don't write a whole paragraph. I mean, that might mean that you have actually copied the entire thing. But just write like in short form, like conditions for normality or things like that. Right? T distribution has thicker tails. Okay, this property we already know. So slide 16. And if what happens when n is large for a t distribution? So when n is large, it behaves like a normal, right? So slide 18, 19 to 20, 18 to 21. So this slide is important. If you see here, maybe I should also point for those students who didn't show up. I should give a star sign so that is the tool draw, right? The red. So this is the question I might ask. Okay, what is the shape of t distribution as the degree of freedom increases? This you guys should know by now. Like if n is large, it approaches normal, and graphically the t distribution should look something like this, right? If I say that plot a graph for normal and t distribution, it should have this shape. Like you have to first draw the normal curve, and then you show that t distribution has a thicker tail, right? Usually they have a thicker tail. Right? So the t tail is thicker than the normal. So slide 18, 19, 20, 21 important. Finding a t-stat. These kind of questions, like the quantitative question, will mostly come from chapter 5 of the statistics component. Right? I didn't test this in the midterm, but I will maybe give like this example, right? Similar to this example, not exactly this one. You should know how to find the test statistic. Okay, in this case. And for t statistics, the degree of freedom is n minus 1, right? That you guys also know that it has to be n minus 1. If you don't find that n, it will give an incorrect estimate of that. Right? So yeah, slide 26, very important, maybe for the purpose of the exam. Finding p-value, all right? Finding p-value is also important. So when you have the t-value, you can find the p-value for one tail or two tail. So if let's say if I give you like 3.25 of the t-value, and if the degree of freedom is 9 in this case, right? 3.25 and 9. The corresponding p-value is 0.05 for one tail, and for two tail it would be 0.010. Right? So that p-value also is important regarding the exam. If I tell you find the p-value. We also need to know the confidence interval, so you guys have to use this type of formula, point estimate. It should be in your formula sheet, basically slide 42 of chapter 5. Make sure you have these things, like if I say find the confidence interval for a sample mean, a small sample mean. So these things also you guys have to know. So slide 48 has the worked example, right? So slide number 48. So yeah, 3-4 questions would come from chapter 5, and the descriptive questions would actually come from the econometrics part, right? I am not covering the synthesis part, and maybe it's not, and paired data I have omitted from the exam. Okay, so paired data is from slide 60 to 67 or 68. You don't need to worry about the paired data. Another example here, like calculating the test statistic. So look at slide 76. Okay, just for the sake of revising. So that's important for our exam. So is there any question? Like these things should be pretty like we have done a couple of times in class, but I agree that if we did it like maybe 5 to 6 weeks back, you still need time to recap. Watch the video, maybe especially these slides. Okay, it will help. Also slide 78, this is a nice example. Slide 78. ANOVA also I am not covering that much, so 79 to maybe I just skip this ANOVA completely. Alright, no need to focus too much on that. But you guys need to know F distribution, alright, which is slide 96 of chapter 5. So there are some examples. So from 102 to 100, maybe 6, you have to look through the example. Right? 102 to 106. Okay. So that's chapter 5. Okay. Any questions or any problems regarding that? So no ANOVA, no paired data. These are the only stuffs that are going to, the quantitative stuffs that are going to come in the exam. So that's about chapter 5, and I'm recording the session so that those who are absent can view it. So let's now go to the Woolridge. I'll go a little slower, because for recap purpose. So from chapter 1, they have some few examples on like crime, the model, and also a wage. I usually like the wage part, right? So maybe read this on slide 7. Like on slide 7, if you look carefully, like you should know what is the dependent variable, what is the independent variable, and what does u mean. U means these are like unobserved determinants of which, like the factors that is not captured in the model, right? The unobserved part, and usually the u is the error term, right? Sum of squared residuals. Okay, sometimes we call this SSR. So slide 7 can talk details about it. In fact, in chapter 1, we don't have much theory, but they are describing like what is a pool cross section. So some definitional questions can come, like what is pool cross section, right? You guys need to know, or what is a panel or longitudinal data, right? So panel data is slide 16 and pool cross section is slide 14. Okay, and what is time series? These are just definitional questions. So time series is slide 12. Okay, so chapter 1 of Ulrich, slide 12, 14 and 16. From chapter 1, only these three definitional questions might ask, like distinguish between time series, cross section, or a panel data, right? So if you guys know this, then it will be easier to write it in the exam. Like this kind of question can come, like what is the difference, or what is the between pool cross section, time series, and panel or longitudinal data, right? So that's from chapter 1, only 22 slides, but you guys need to know only the definition, and slide 7, because I can ask what is a U here, or unobserved characteristics. So slide 7. Okay, that's from chapter 1 of Ulrich. Any questions? You guys should know like what are the differences. Like I have covered in class. Unfortunately, for chapter 1, we don't have a video on the YouTube channel, right? That day I think I forgot to bring my HDMI, so I was not able to record it. Okay, don't spend too much time on like I just recommend go through the slides, okay, and maybe from the homework questions. My pattern is usually what I teach in the class. I usually test based on that. So, okay, I will open this point. So simple regression model. Okay, on slide 2, it's like similar to. Actually, let me find the PowerPoint PPT. Okay, it's easier to discuss from there. So slide 2 is like similar to slide 7 of chapter 1. Okay, so both of these are talking like about the same thing, right? But this is more in a general form. Like there's not a wedge equation form. Like it's like y equals to bx plus u. So in general, so I can ask the question in terms like give the example of an unobserved characteristic, okay, in terms of a wedge equation model. Then you have to use a specific example of slide 7, right? Then what would be the unobserved characteristic for wedge that we do not observe? Ability, right? Ability can it be observed like visually or no, right? So that could be an unobserved characteristic, right? The wedge equation of slide 7. But if I say give a general notation of an unobserved characteristic, then you just write like this: y equals to b naught plus beta 1 x plus u, and you mention like y is the dependent variable, x is the independent variable and u is the error term or the disturbance, right? So general notation is like this: error term, disturbance, or unobservable. Like they have many names. And similarly, independent variable can be called as regressor or explanatory variable. Right? Usually, it's nice to write. If you are in your paper, you can say the regressor was this. Instead of saying independent variable was this, it's a nice way of saying the same thing. So they have few more examples, and you guys need to know all the 5 assumptions, right? So 5 assumptions, slide 5, which is conditional mean independence assumption. Okay. Slide 5 of chapter 2. This assumption for a simple regression model. In fact, in the quiz which I gave in the class, I uploaded the quiz as well. Like I said, give the conditions for simple regression model. So descriptive question like this can definitely not can, but I think it will come in the exam. Okay. So conditional mean independence assumption that the error term u given x, error term given the like independent variables is 0. That means error term is not influencing the independent variables. Okay, so that's assumption 1. So a few more examples here. Okay, you can read the example. I might ask the algebraic properties of slide 15, okay, of chapter 2. Okay, like sum of ui's is 0, or sum of x given ui hat, the estimated ui, the covariance is also 0. So these are the algebraic properties of an OLS equation. So I can ask that, and also the fitted values and residuals, right? So properties of OLS on any sample of data. Let me magnify this one a bit. All right. So that's slide number 15 of this chapter. You guys should know what sum of square total, what sum of square explained, and what sum of square residual, right? These things are important not only for measuring the variance, but for measuring the R square. We need to know all of these 3 things. So that's slide 17, very important. Definitions, like you need to know like what's happening. Like it's the if sum of square total is like yi minus y bar, right? And in class I said many times that why do we square it? Brandon, do you recall like why do we square it? Because we want to measure the variation in terms of a positive value. So the variation could be negative or the variation could be positive, right? But squaring makes it sure that the variation that we get is always a positive value, right? You can write the formulas definitely on your cheat sheet, right? So and y's are the dependent variables and x's are the independent variables. We know that, and u is the error term or the unobserved part or disturbances. They have many names. And this formula should be definitely in your formula sheet, right? Slide 18. This is recorded, this session, so those of you came late or some of you guys might be not present in class. Slide 18. These formulas should always be in your formula sheet. And sum of square E is the sum of the explained part, right? and SSR is the sum of square residual, is the unexplained part. Error term is always the unexplained part, right? We don't know what's going on there. And SST is the sum of square total. So slide 18, very important. And the interpretation of the regression coefficient. So this is, if you see log form on the dependent side and no log form in the independent side. Okay, so then how do you like interpret the coefficient of beta 1? You have to use this type of formula: change in log of wage over change in the education variable, right? It's like a differentiation of the numerator is the dependent part and denominator is the independent part, right? I actually did this in class, so this part I can ask, or I can flip it, like I can say if log is here. Okay, tell me one thing, if both the not numerator, denominator, but if both dependent and independent variables are in log form, then what is the coefficient, like what does it measure? The elasticity, right? The change in y with respect to change in x, right? So it's very simple, like a differentiation point of view. When you do a change in y with respect to change in x and both are in log form, it measures the elasticity. Right? It's easier to interpret that. Okay, so slide, what was it? Slide 20 of chapter 2. And definitely slide 24 is the most important. If your dependent variable is y and it's x, then the interpretation of beta is this. Okay, you can write this in your formula sheet. Okay, it will be easier then to answer like a question like what if the dependent variable is in log form and the other one is like in just a linear form. So how do you interpret the beta 1 coefficient? Then you can say that it's a change. We have to do like change in y with change in x, and eventually it will come to like this, like the log level. Okay. When both are level form, like both are linear form, then 1 unit change in x is 1 unit change in y. When both are in log form, then percentages, as Mike has said, that if x changes by 1%, y changes by this much percent. It depends on the beta 1 value, right? So when both are log form, percentage change. If both are linear form, then unit change. But when one of them is different, like one is log, one is beta, then we have to be careful in saying the things. Right? We covered this in the statistics part as well, right? These things. So assumption 1, yeah. So these are the assumptions. It should be linear in parameters. Definitely slide 26. This will come in the exam. So you will be rest assured about this. It's linear in parameters. It has to be randomly sampled. Okay. So those are the two assumptions, and there should be variation in the explanatory variable, right? That there should be variation in the x. If there is no variation in the x, you cannot do a regression. Like if all of you guys in the class have same GPA and I try to do a regression, that how many hours they have put, will that affect their, no. Let's say if all of you guys are putting the same amount of effort, that's like the independent variable, right? How that would affect the GPA? GPA is the dependent variable. So if all of you guys, there is no variation in the X, then it will be difficult to interpret the GPA, right? So there should be variation in the independent variable. That's assumption number 3. It's very important. If you find a data set where all your independent variables are similar, right? Let's say you are trying to see how obesity, like weight of a person, affects their health, right? But if in your sample all of the guys are similar in weight, like all of them are like 150 pounds, no variation in that, you cannot interpret the health, right? Health outcome. So you have to have variation in X or variation in the independent variables, right? Fourth assumption is the zero conditional mean, which actually I discussed. So assumption 3, slide 29 and 26. Okay, 29 and 26 of chapter 2 definitely would be in the exam, so 3 stars. Zero conditional mean means when your independent variable okay does not contain any information, okay, about the mean of the unobserved factors. For example, if your education level of your education does not contain any information about your ability, then it satisfies the zero conditional mean. But in real world, it does have some information about ability. The level, like if you have a master's degree or a PhD degree, that signifies maybe the ability. It's kind of signaling. Okay, so if you guys are interested in the future, if you want to study labor economics, okay, I wish that we had some undergrad courses in labor economics in our department, but that's mostly in the graduate level. You guys will learn about the signaling. How do companies hire someone? They don't know about that person, like if they're good at their work or will they be good at their work or not. So they basically see their resume, right? They look at their education level and the years of work experience, like if they have done a lot of internships. So I recommend you guys to also apply for internships and try to gain some experience before actually going to a full-time job. That might help. If because not everyone will go to the line of academia, right? It's insane to think that all of my students will go to academia and do their PhDs. Obviously, I would have loved that all of you guys go for higher studies, but some of you guys might be working. So for those people, you should try to gain some internship experience before, especially in your junior year or senior year. It's a good time. And assumption number 5, also is like homoscedasticity, right? So the value of the explanatory variable must contain no information about the variability of the unobserved factors. Not only it does not contain the information about unobserved factors, but it also should not contain any information about the variability of the unobserved factors. So the variance basically should be similar, constant, like sigma squared. Otherwise, we cannot do an OLS regression. That's why I told you guys to do head test. Remember, like some of you guys were struggling. The head test was like it was varying. That means it was influencing the variability in the error term. That will bias the OLS. So it has to be constant. So I told you guys to redefine your model, drop some the multicollinear variables, right? Checking the VIF, you can drop some of the nonsense variables from the model. So slide 31 is important. Okay. Any questions? Like the assumptions of, because these are all descriptive theoretical stuff. Okay. I cannot change much on this. If I ask you describe the 5 assumptions, can I trick you guys? No. These are descriptive stuff. I can't change the things. For numerical questions, maybe I can twist a little bit here and there. But descriptive stuff, it's the theory. How can you change the theory? Okay, that's about it from chapter 2. In fact, chapter 2 is one of the important chapters. Okay, 2, 3, 4. These 3 chapters are very important for the exams. Let me just save it just in case. Okay, and I would like to mention, like, the slides that I have got. Okay, I have to give due credit to my colleague. His name is Igor Moko. Okay, he actually, the Ulrich textbook slides, there were more slides. He has reformed it in a smaller slides. Okay, so it's more understandable. So I should give due credit to my colleague. Okay, so you guys should know that these are actually his slides. He was very helpful. I told him that, yeah, I'm trying to teach, so he'll help me with these slides. Right. One of the smartest guys in our department. Okay, so multiple regression model. You can just read this example on slide 4. This will give you some information. Okay, the example. Again, I would ask the algebraic properties. Okay, it would be similar in nature to the OLS. So it's slide 10. Pretty similar, the algebraic properties. Right. Just like the OLS regression, they also have similar algebraic properties. Like sum of the residual is 0. Otherwise, you cannot do a multiple regression. Right. The covariance between the independent and the error term should be 0. It should not influence each other. Right. Similar R square, similar the sum of square total. Okay. So goodness of fit is similar. Okay. But in slide 11, R squared does not necessarily mean that. Not that. What happens when we add another explanatory variable? If we add more independent variables in the model, it would increase the R square. But is it logical to just add randomly any explanatory variables just to make your like R square bigger? No, right? Maybe it's increasing the R square, but maybe it's not improving the model. Okay, you can add a lot of variables. Like instead of 5 variables in your model, you can include 30 variables in the model. That may not necessarily improve the model. It might improve the R square, but may not necessarily improve the model, because some of the things might not fit with the model. Now for estimating wage, if I add like let's say some nonsense variable like let's say how many furnitures do I have, or something like that, or which has nothing to do with wage or anything, so that might not fit the model that well. Okay, so adding variables would increase R square. So this is like a question, slide 11 of chapter 3. Okay, what happens when we add more variables in the model? You can write it would increase the R square, but may not be may not improve the model. Okay, may not necessarily improve the model. So the assumptions, so slide 14, Assumptions for a multiple regression model I asked in the quiz which we had in the class. Slide 14 of chapter 3. Assumption number 1, linear in parameters. Same like random sampling, same like the OLS, right? No perfect collinearity. We didn't have collinearity issues for a simple regression model. Why? It's just one variable. How can it be collinear, right? But now when you have more variables, if the VIF indicates it's greater than 10, that means there's perfect collinearity in the model, right? So Amna, I think, was having like a high VIF initially, right? Then you redefine the model, you dropped some of the collinear things. So that's a good modeling. Like you can't keep perfect collinear models together. It can be like indirectly collinear, that's fine, but no perfect collinearity, right? So slide 15 very important. I can ask like in Stata, like how do we test perfect collinearity? You can say we can test using a VIF test, which is called the variation inflation factor. We also have in slide 17 the zero conditional mean, just like the OLS, right? Okay, so for omitted variable bias, okay, this is the trickiest part, and I think I told you guys that this would come in the exam, right? So slide 19. To 21 you guys should read. They give a good example of the omitted variable bias case. So omitted variable bias, so let me just recap. So let's say beta 3x3, this is one of the important variables in your model, but if you don't have it in your model, like I think again I would say Abna's example, like you had some omitted variable bias, like maybe some of the variables for the analysis was missing. So if it is missing, what's happening is like when you are regressing y on x, right? We might see that the coefficients might be slightly, maybe it might be for omitted variable bias, it can be positive, the coefficient could be greater, or it could be also lower in value. Okay, it depends on the direction of the bias, right? If it is bias upward or whether it's bias downward. So if it is omitted, then if you see, because x, then if x2 is like a function of x1, then when you are estimating x1, you see there is an extra term, beta 2 delta, right? So what we are doing is we are slightly overestimating the this coefficient if the direction of bias is positive. Okay, so it can bias your results, but it would still give you maybe the right direction. If your coefficient is positive, it will still give you positive direction, maybe it's slightly bigger. If it is negative, it will give you a negative direction. So omitted variable bias would bias the coefficients if you drop like one of the important variables from your model, right? Like when we are estimating wage equation, we for wage, what are the important characteristics do you think you need for your independent variables. Estimating wage, you need education, you need experience, and you need ability maybe, right? But we do not have a direct measure for ability. So for ability, maybe you can see like some people use like IQ score, something like that. So if that variable is not in the model, it would overestimate the value of education and experience because you have omitted ability from the model, right? Because ability should also have some value, but since you dropped it, what the regression would do is they would give those values maybe to the other variables. Okay, this is in layman's terms. You don't write like this in the like you can just give this equation. Okay, make sure you guys can write it down in your formula sheet. Okay, slide 21. And just give this example that what happens when there is omitted variable bias. And also homoscedasticity should be there. Like the explanatory variables should not contain any information about the U. Not only that, it should not contain any information about the variability of the U. Right? So that's one of the important assumptions. So all are similar, like OLS, multiple regression model, similar in nature. DIF, I'm not going to ask much of this. Okay. And these 5 assumptions are also called the Gauss-Markov assumptions. Okay. That determines the efficiency of. So maybe slide 34. Just recap a bit of chapter 3. Any questions from chapter 3? So 2 and 3 pretty straightforward, no complications, it's just pure theory. And if I ask any question, it would be just the same thing, right? I can't twist any things from there. So that's chapter 3. And again, it's webcasted, so those of you missed like maybe the first 10-15 minutes, watch it on the channel. Okay, now the inference part. So inference is when the error terms are normal. Okay, so when the error term is normal, so combination of the Gauss-Markov assumptions, which are the 5 assumptions as I stated before, and when you have the condition number 6, which is even your error terms are normal, then we can say that it is it is a blue estimator, based linear unbiased estimator. Okay, when is it blue? When it satisfies all 6 conditions. So the 6th condition is on slide 3 of chapter 4. Okay, and once all these all 6 conditions are met, then we will say that our estimator is blue. Okay, and I am writing in blue. So it's based linear unbiased estimator. Okay, so for inference, we have to do usually like a hypothesis test, right? And what is the convention for a hypothesis test? Usually, what do we say as now? We test whether that coefficient is 0 or not, right? So when you use the convention null, that coefficient is 0. So that's usually it's in slide 5. Okay. So for inference we have to do hypothesis test, and for hypothesis test usually you will see most of them are t-test, right? And we usually set the null to be 0. That's the convention. But you can set anything. Like you can say what's the mean age of students taking this course, maybe 17, 18 or 20. You can just set your own null, right? But by convention we use 0, and then we do a t-test. And once we get the t-test, if the t-test is large or if the p-value is small, then we reject the null and we say that that coefficient is significant and it is important for the analysis, right? So initially you say that there is no difference in the coefficient, so you assume the coefficient to be 0. But once we reject the coefficient, it depends on the t value and also the p value, right? So p value is small, you reject the null, or t value is large, you reject the null. Okay, and then you say no, this coefficient is important for the analysis, and they make a difference. So you guys can read slide 7. It will give you a better idea. And also slide 9. I'm not going to test slide 9, but just for your understanding purposes, but I can give a similar type of example, and you guys might have to find you might have to set the hypothesis. Because slide 9 cites slide 12. And not only it's the one-sided test, it could be also two-sided. So that's slide 15 of chapter 4. Okay, slide 15. So for two-sided test, the p-value and the t-stat is different than a one-sided test, right? So now the area is on both sides. This side, on this side. So you have to look at the t table in that case. Usually I think I have uploaded the normal and t table in the exam, but I'm not going to ask any two-sided test in the exam. Okay. So this is for your knowledge only, all right? And this table might help, like whether it's significant at 10% level or 5% or 1%. Slide 17 would help you determining whether they're significant at 1% level, 5% level, or 10%. Okay, and it's the modulus of t ratio. All right, so t could be both positive and negative. If it's on the right hand side, t would be positive. If it's on the left hand side, it would be negative. But we usually, when we interpret the level of significance, we take the modulus of it. Right? Computing p-values, it's similar like how you compute the p-values for a simple regression. If you have the t-values, you can go to the t distribution and you can find the p-values. The confidence interval, yeah, maybe one question. Total, I will give you guys about 8 to 9 questions in the exam. Okay, maybe 9. So from each chapter, you will roughly have like 1 or 2. From chapter 1 of Ulrich, it's only one question because is cross section, panel, and time series. Right? I can't create 2-3 questions on chapter 1 of the old reach. Right? Chapter 1 was only 20 slides, and it's like, what is the panel data, what is time series, what is cross section. No theory that much. So maybe 8 to 9 questions will be in the final. Right? So confidence interval is slide 24 of chapter 4. Okay, 24-25. This will help you understand chapter 4 better. I think I did spend a lot of time on this, on the multiple regression analysis inference, right? 27 to 30. Let me check the YouTube channel. I think I showed it in class. I think I spent from chapter 4. It should be it should be on the blackboard, I think. Usually I put the links, right? Whenever I am uploading a new video. The chapter 4, yeah, this was chapter 4, and especially towards the end of the chapter, I think I was yep. So which slide was it? Oh no, it's the different one. Yeah, it's not this Yes, this one. Okay, so watch my lecture 16. Okay, especially the last 6-7 minutes, right? Watch lecture 16. The last 7 minutes, I think, are very important. This would definitely be the exam question. Okay, and that's slide 28, I think. Yes, the variability. So lecture 16 on my YouTube channel. The last 10 minutes are extremely important. So this question would come in the exam. Okay? So watch it. I have explained what happens when because in a regression coefficient we don't have the covariance. Okay, standard error of beta 1 minus beta 2 is root over variance of beta 1 minus beta 2 hats, right? So when you break it down, it should be variance of beta 1 plus variance of beta 2 minus 2 covariance of beta 1 beta 2. But usually in a regression output we don't have this covariance. So how to solve that? We have to define a variable, right? And when you define a variable, only then, like if you watch my video, like the last 10 minutes, it will be clear of lecture 16. So that question would come from for the exam. Okay. So let me write it here. Lecture 16 video, last 10 minutes. Alright, I'm not spending much time because I need to and also the joint significance. I also discussed this many times in class, right? Maybe your variables are not significant individually. You can run into that problem, right? Some of you guys were not finding significance jointly. Then what? Not jointly, like individually. What you can do is you can set all the coefficients to be 0 and then test for it using joint significance. So slide 36 and 37 of this, and you should also have this formula in your exam sheet. Okay, slide 36 and 37 of chapters 4. So 36 is important for joint significance, and slide 37. Okay, and then if you reject the null, that means your variables are significant jointly, right? So for f, tell me how many degrees of freedom do they have? How many types of freedom? Two types of degrees of freedom. So for f, you have, see, 4 and 83. So what is 4? 4 is the number of restrictions. How many restrictions do you have in your model? That means you have set 4 of your variables to be 0. There is 4 restrictions. And what is 83? 83 is n minus k minus 1. N is the number of observation, k is the number of regressors, and minus 1 is just for minus 1. Like t also we do n minus 1, right? So if I give you guys an F test in the exam, you should know they have 2 types of degrees of freedom. Okay, so I will show you guys the F test that you guys should know. Let me show you guys the F test. See, F test table have degree of freedom 1 here and degree of freedom 2 here. Okay, let me use a magnifier. Is it visible? Right? So degree of freedom 1 means the numerator part. in the numerator part, it's the number of restrictions. Like if I so I'm writing on board. Let's say y equals to beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus u, right? If I have three restrictions, 1, 2 and 3 equals to 0, this equals to 0, this equals to 0. What would be my degree of freedom for the numerator part? 3. Right? 3 restrictions. So q equals to 3. Q is number of restrictions. And if I have n is let's say 90, k is the number of regressors. Okay, here is like 3 and minus 1 we have to do. So 90 minus 3 minus 1, 86. Right? So then you go to 3 and maybe you should go to 83. That will give you the critical value for f for that particular point. Is that clear? And then if I say that based on the regression you got an f value of, let's say the critical value is 3.2 and from the regression you got 4. So then do you reject the null? Yes, because your f value is greater than the critical value. So then if you reject the null assumes that they are jointly significant, they are all 0. So if you reject the null, that means they are not all 0. At least one of them might be greater than 0 or less than 0. So they are jointly significant. Is that clear? I think I covered that in class as well. Let's see, it should be maybe the next class, 17, lecture 17. Yeah, I talked about the here, I think. So that would be 17 minutes to okay, 17 to 27 minutes. Okay, roughly, but I need so for this watch lecture 17 on the YouTube channel. Okay, 17 minutes to 27 minutes. So lecture 16, the last 10 minutes very important. Lecture 17, watch 17 to 27 minutes. It is described in details. Okay, so that's about chapter 4. Is there any questions, like if you are still confused? And I hope most of you guys are almost done with your paper. I have got 5 submissions. We have about 11 students, so 6 more submissions are pending. I hope to get in by maybe the next couple of days. 14th is the deadline because I have to submit the grades on 15th. Alright, now only 2 chapters left and both of them are like 10 slides each. So not big chapters, those 2. Basically there is like talking about this slide is the important slide, when we can take log and when we can't. This will come in the exam. Okay, definitely coming. Okay, rules for taking log. You cannot log small values. You cannot log percentages, right? You cannot log years. So you just read all these 6-7 conditions. Right? So slide 2 of chapter 6. Slide 2, not 2. Slide. Important. It's coming. The marginal effect. Okay, so marginal effect is important. I think it's on lecture 17. In fact, I recommend you guys, if you guys have time, watch lecture 17 and 16. Okay, at least these two lectures, watch it. The bare minimum. It's like 1 hour, 1 hour. You don't have to put much effort. If you watch the entire these two lectures, then you will be confident in answering most of the questions. Okay. These two chapters are very important: the multiple regression and the issues of the multiple regressions. Right. So they talk about the interaction terms, the adjusted R square. Okay, what is an adjusted R square? Slide 10. You guys need to know the adjusted R square. This should be in your formula sheet. Right? What does an adjusted R square do? It penalizes you to if you are adding new regressors in the model, right? If you just nonsensically add 10 more variables in your model and you claim that the R square is big and so it should be used for the analysis, but the adjusted R square will penalize you if you add those variables, right? So then you have a fair comparison. Okay, so lecture 17, I recommend you guys to watch it. I will ask a question about adjusted R square. Just slide 10, chapter 6. So that's about chapter 6. This question is definitely coming, when to take log and when not to take. So descriptive question. Slide 2. Now the last chapter. Last chapter is about the dummy variable trap. Okay, so you cannot use both dummies together, like male female, in the model. Like what is the problem with that? So that I covered in my lecture 18, which was just a 15-minute video, I think, for lecture 18, right? So basically, read slide 4. Maybe 5 and 6. 4 to 6 of chapter 7. Chapter 7. We didn't cover chapter 5 because I thought that it's not really useful for this course. So that's about it for the exam. So if you guys have any questions, feel free to ask. Now is the time. And that's what I'm going to ask, like 8 to 9 questions. And I recommend, if you guys have time, at least see lecture 16, 17 and 18. Okay, 16 is, I think, like 1 hour something, and 17 is 1 hour, and 18 is 18 minutes, 15 minutes, and go through the review class. This will help you prepare well for the exam. Okay? So that's about it. So if you guys have any questions, let me know now. We can just end now, and wish you guys all the best for the finals on 13th. Okay, make sure you guys like come early. It's I think at 10:15, right? Let's look at the syllabus. It should be at 10:15, 13. There is no makeup exam availability. Okay, even if you're sick, if you are medically, if there's a medical emergency, what I would do is I will give you an incomplete grade I, so that you can take the class next with some other instructors for the final. So if you're medically sick, if you can't come on 13th, I hope nobody is medically sick, because there is no makeup exam availability. Just after the exam, I have to post the grades. On 14th, I have to submit everything. Within 72 hours, I should post the grades. Okay, but I usually do it within 48 hours. Okay? So that just sometimes if the system is down, that there's a risk of that. So I cannot take any makeup exam. Like you cannot say that, oh yeah, I will take the exam 1 week later. You have to take it under a different instructor, and maybe it might be like a different topics altogether, right? So it's your own risk. So don't miss the final, right? Unless you're really sick and like you can't come and something really happened. But I will give an incomplete grade in that case. It's 10:15 to 12:15. So you will have 2 hours to answer 8 to 9 questions. Okay? Final is 30% of your grade. Paper is 15%, lab is 15%, homework is 15%, 45%, and midterm was 25%. Okay. So, and there's one good news for the homeworks. Those of you submitted me homework 1, 2, and 3. Initially, I gave them points like 8, 9, right? Everyone got different scales. I'll just, for sake of simplicity, I'll just give full points to all of you guys for the homeworks, just for attempting. Okay, I didn't mention it previously because if I mentioned it, nobody would have done the homework seriously. But now, I'll just give them everyone full score in the homework. Okay, so you get 15 points, regardless of, like maybe you got 12 or 13, but I will just make it 15 for everyone. Those who have submitted all the homeworks. All right. Labs, most of you guys attended most of the labs, so labs also you guys are getting the full score. So try to do well in the final. Okay, that will help you get a good grade. Okay, yeah.
You're gonna be in here.
Wait.
The finals will be in this classroom.
Yeah. Finals will be in our regular classroom. Okay, just 8 to 9 questions. It's very straightforward. Whatever I did in class is just coming from there. Okay, thank you guys, and have a. I wish you all the best for this exam and the other courses. Yeah, submit the paper email, submit the data file, submit the do file. If you do it in other software like R or SPSS or Excel, then submit the codes in that software.
Is that alright if we just, do you want it all on email or do you want it in Dropbox?
Email is better.
Okay.
Yeah.